what is the sun? Quickly, the sun is a star. The sun is a big, massive ball of hydrogen that's turning into helium. There's some other elements in it, but basically it's an enormous nuclear furnace. Combining hydrogen, everybody has fists, right? You get some fists on it. Do this right here, and then that. That's basically what the sun does. It's a little more complicated than that. It takes hydrogen atoms, about 690 tons a second, converts them into helium atoms, and lets off a little bit of energy via a fairly famous equation. I think that you've heard of, E equals MC squared. That 685 million tons ends up being about 684.8 million tons after it's taken place. And the remainder is converted into energy. And that's why we all are alive, and that's how everything you see and hear, me, this telescope, Dr. Dundee, my phone sensor, that's how it all came to be, how it all works. So it's a fairly important star to us. I'm very fond of it. I wish we'd seen a little bit more of it this week. This is the sun in a certain wavelength of light, which brings me to what these scopes do. There's two types of solar telescopes. Well, there's several, but there's two mains. There's those that reduce the brightness in all the wavelengths, like the solar glasses up there, or what they call a white light filter that takes all the wavelengths of light and reduces them down about 1 to 1,000, so you can look at it. And then there's the scopes that segregate out different wavelengths of light. Everybody see the little chart here, the electromagnetic spectrum? That's a fancy word for all the different wavelengths of energy. The sun puts out light in every one of those wavelengths. All we can see with our eyes is this little section here. These telescopes will take one little sliver of that and look at that wavelength only and not reduce the brightness. Okay? And the other type of telescope will take all the wavelengths and reduce the brightness. And there's two purposes for those we'll talk about this. When did solar photography start? Well, this was a breakthrough, absolutely incredible photograph taken in 1860. If anybody recalls, Albert Einstein's theory was, I'm glossing over this, but it was verified by a solar eclipse in the early 1900s. Surprisingly, this guy failed to take any photographs. The whole theory was verified by stars, light being bent around the sun during a solar eclipse. This is really the first, I say first, but we're so arrogant in our European ways that we think we're first at everything. This is the first European solar photograph. The Chinese and the Mayans and Mesoamerican cultures have been studying the sun for thousands of years. While we're using stars. Galileo, of course, is a big shot for us. We all think that he started everything, and he did do a lot of sketching. He used a standard telescope with really not very high quality objective. It's about the size of this scope, but a bit longer. All right. And he discovered a lot of stuff. You say discovered. He looked at a lot of stuff first. He sketched these sunspots, and the big rumor is he went blind looking at the sun. I don't think that's true. He may have had some ill effects from sighting the sun, but I doubt he was blind. He projected the sun's image on a piece of paper and then wrote a sketch over the piece of paper. And he came up with several of these sketches and found out that these sunspots rotated around the sun, which means the sun rotated. So that's kind of an early solar sketching. Do you have a cell phone camera? Who has a cell phone? Everybody have a cell phone? I have a cell phone. If you have a cell phone camera, you can take photographs of the sun's effect. Has anybody heard the phrase red sky? Red sky at night, sailor's delight, red sky in the morning, sailor's morning. Being a submariner, I never saw the sky at all, so it was relevant to me. But it has something to do with clouds. I guess they're always, if the clouds are east of you, it's going to be future. But every day and every night, if there's clouds in the sky at all, you see this beautiful red, purple, violet, orange transition on the bottom of the clouds every day, sunrise and sunset. And that's when the sun is just on the horizon and it's shining through our troposphere or atmosphere, and it's casting light on the bottom of the clouds. This is really an ideal device to take a picture of that. And that's me, of course. One of the things about a cell phone is that it doesn't really have a lot of good exposure control. So if you put your face in front of it like this, you get a really bad picture. This cell phone doesn't work too well for that. Okay. Cloud-affected skies. This is the skyline over the Atlanta Air Traffic Control Center, which is the busiest facility in the world. This is about right at sunset, and the sun is right in this area here. Or actually, it's not up there, I guess. And you see the clouds kind of look normal. They're starting to get a little bit of an orange twin engine. These are all taken with this cell phone hanging out my truck window. Okay, when there's no special anything needed. And then just a few minutes later, it looked like that. This red, you know, a lot of people never look up anymore. I'm not sure why, but we can all probably go through several days without even looking up. You know, we're so busy with all our money-making agendas and such. I look up all the time. I'm always walking around. People are always looking at me like I'm crazy. But there's a lot of beauty outside, especially the sunrise and sunset in the middle of the night. But every day and night you can see this, especially if there's a few clouds. Do everybody know what I'm talking about? It just gets redder and redder, and then it goes to violet, and then it just fades away. And I tell you, there's something to reaffirm spirituality is watching that, especially in the rough days. Those air traffic controllers have come in rough days. The cell phone is not all that great for taking a picture of the sun. You can do it, and some people think this is very artistic. And the way I took this photograph was by putting those glasses over this and pressing the button. And you can do different things with different cell phones. You can zoom in. I've seen several people use a cell phone on a telescope and take a pretty good photo of the sun through a telescope, or even just with the phone only. You have a zoom feature. Okay, so if you have it, go out and do it, and just do it a couple times and really appreciate what's going on. The glasses are free, of course, and feel free to duck them around your cell phone and walk around like that all day. Just don't drive with them. Point and shoot cameras. Does anyone here own a point and shoot camera? Anybody get one for Christmas? Okay. Okay. A point and shoot camera is a camera that does not have generally many manual settings, and the lens is permanently attached. Okay. So I need a. Would you mind being my volunteer? You want to be a volunteer? Come on up. Either one of you. This is a long-term commitment. Can you be the sun so we can practice taking photographs? Is that all right with you, Mom, man? Let's see. Uh-oh, backwards. Oh. There you go. Stick your hands in there. All right, nice job. Now we're going to act like this is the sun, okay? Point and shoot cameras will take photographs of anything, and the main thing when you're dealing with the sun is not to use any device where you look through a viewfinder, because any kind of magnification of the sun to your eye will blind you very quickly, and you won't feel it because you don't have any nerve endings in your eye. So by the time you even know it's done, it's already done. So these viewfinders on these cameras are great. I can sit here and take a photograph. We're going to act like, uh-oh, that's video. We're going to act like he's outside. I got a great photograph of the sun. Thanks. You can have a seat in that, or you can just stay up there with me. I got something else that you or other friend can help you with. Point, anything you want, whatever you want. Point and shoots will take a magnificent photograph of the sun. I took a couple of shots at that same sunset over work. This was just last week, you know, when I was out on break. And this is also hanging out in the truck window. And you see in this shot, the orange is starting to turn yellow, and the red is still there, but it's fading. This beautiful blue velvet. Okay, and these point and shoot cameras are so advanced now that they're really ideal for getting these shots. So I would like for you to, if you can, look up at sunrise or sunset tomorrow and take a picture, because I promise you, you will be surprised at how beautiful the work is. That's the same image through a point and shoot. Cell phones are so advanced now that a point and shoot and cell phone image are both pretty much about the same if you hold it steady. Okay, if you shake the phone around and you send a text message, it's not going to look to you. That's what the sun looks like in a point and shoot. Thank you, volunteer. We're just going to call you Sunny for now. This is just pointing it at the sun and taking a photograph. That's beautiful to me. I mean, I know that this is something you see every day, but when you think about what you're looking at, there it is, and you can take this with a point and shoot or a cell phone. To me, that's just an amazing fact that we're rotating around this enormous ball of pine, and for some reason we're still here, and it gives us life. To me, it's just amazing. That's the sun with my glasses duct-taped over that camera. You know, it's a little bit better than a cell phone. You're not going to get a lot of detail on the sun. So these images, you know, this is also the sun, and this is just taken out in the woods by my house just one day last week.